Hi students, welcome back to my YouTube channel SADHIK Physics, where we are learning the physics very easily, right. So we started wave optics. In this one we already discussed interference, Huygens wave theory and Young's double slit experiment and theory and different applications and problems, and also we completed the diffraction, no, and one more final topic, no, so that is polarization, no, we are going to discuss in this topic now. Clear? So polarization, no, right. So this is also like a wave phenomenon, no, but Huygens principle could not be able to explain this polarization, no. See, therefore interference and diffraction can also be applicable for longitudinal waves and transverse waves, no, but here therefore polarization can be applicable for only transverse waves, no, therefore longitudinal waves will not show any polarization, no, that is why light is said to be in the form of a like a, so transverse in nature, transverse wave. How you can tell that light is a transverse wave? No, because it is going to exhibit the polarization, right. So what is this polarization? You might have see mostly the players, like cricket players, they will wear some goggles, and these goggles also. So these all are nothing but like a polarized glasses. So that means the intensity coming and falling on this, the intensity of the light is going to get reduced by this glass, no. So therefore the intensity receiving to our eyes, no, it will be lesser. So that means, so therefore certain amount of light is getting blocked. So that's why even we are staying in the sunlight. So by wearing the polarized goggles, no, therefore you will not feel that much intensity receiving to our eyes, no, therefore we feel it as like a cool, right. So that all are nothing but like a polarized glasses, no. So first of all let us understand what is meant by this polarization, no, and what is this unpolarized light, no, polarized light, no, let us discuss now, right. And from this one, you can understand that light is in the form of like a transverse in nature now, right. So therefore polarization cannot be done for a sound waves, like, so therefore it will be not shows this polarization for the sound waves, no, light only it will shows, no, that's why light is said to be in the form of like a transverse in nature now. So let us come to know this one, no, what is meant by this polarization. Let us see this one, no. So I think if you are able to see it, no, right. So let us see, first of all let us see what is meant by this polarization now. Polarization is nothing but we are restricting our light, no, right, our light to vibrate only in one particular plane. So therefore especially that is electric vector, no, we know that light is in the form of like a electromagnetic wave. So what we are doing now, we are restricting our light, no, to oscillate or vibrate only in one particular plane. That is only we can call it as like a polarization, no, right. So therefore here it is particular one perpendicular direction to the direction of propagation of the wave is said to be polarized light. That means we are restricting now. I will explain one concept now so that you can understand very clearly. So YDSC and diffraction, so tells us the light is in the form of a like a wave. Light is a wave. So because we came to know that, so it is exhibiting the interference and diffraction, no. So light is a wave, but which wave? Polarization confirm that transverse in nature. That means polarization will explains that light is in the form of a like a transverse in nature. Longitudinal waves like ultrasonic, sound waves and infrasonic, no, cannot be polarized. Therefore sound waves, no, cannot be polarized. First of all let us see what is unpolarized light, no, unpolarized light. See, so for this one you need to understand this statement is very nice actually. So try to go through it, later on I will explain it, no. So the atoms, okay, how that light is comes out, no? You might have studied atomic structure, no, therefore the transition of the electron from one orbit to another orbit, due to the transition, therefore the energy is coming out, no, energy is in the form of a like a our light, right, electromagnetic wave. So the atoms on the surface of the it is heated, therefore if the filament is heated, so which will generate the light. That means you might have see in a olden days, no, there will be a filament bulb is there, we are going to heat it, no, that hot, no, it will be get commit like a light. You might have see if you heat the like iron, no, therefore it will become like a red, and still more heat, no, therefore it will give us like a blue light, no, like that. So therefore by heating this one, no, therefore we can generate the light. It is independently from one another now. and each of this emission, so the emission of this light no is approximate model like a short wave train, so which is last along the 10 to the power of minus 9 and 10 to the power of minus 8 seconds now. And the electromagnetic wave emitting from the filament is a superposition of this wave trains no, so each having its own polarization direction now. So therefore the sum of the randomly oriented wave trains no result in the unpolarized light. That means, see here, I will explain this one now so that you can get it no. Therefore why the unpolarized light is going to get it no. See, there is an atom is there, this is a nucleus, these are the electrons are there no. So therefore this electron is going to get transition no, or these electrons are going to take it no. This is gives us like a one electromagnetic wave, and some more atoms no, maybe transition may takes place no, this it will gives us like a one more wave no, right. So therefore it will be having almost all possible directions here now. So that means, so one light wave it will be able to travel in this direction no, therefore which is having in this perpendicularity. So another one more wave it will be there no, therefore it may be like this, in this way it will be there. So other one more wave it will be there, so maybe it will be like this in this direction no, so maybe another one more, so therefore it will be like this. Therefore it is having all particular directions. Suppose if you take this is one point no, so it is having along this direction no, along this direction will be there, along this direction will be there, along this one no, this all superposition, therefore different waves. So is coming from where? Different transitions of this sun no. So this all summation gives us like a unpolarized light. That means, so the light wave it is having, electromagnetic wave is having along this direction, along this direction, along this direction, along this direction, almost all possible directions of the emission is there no. This is said to be like a unpolarized, so light, unpolarized light. Clear? So now what we are going to do now, so we don't want all these directions, so we want to block off all these one no, we want to allow the light to travel only in one particular direction, or it is in the perpendicular to this, or it is along the parallel, or it is in the perpendicular to this one no. This is your direction of your wave, either the wave should be oscillate in this direction no, or it will be in this direction no. Therefore only, so perpendicular to this electromagnetic wave, so we are restricting to this one no, which is other side, other vibrations are there no, other oscillations are there no, it is getting blocked. So that is said to be like a, so polarized light, polarized light. So I think you understood no. Therefore unpolarized light is having almost all possible directions of their oscillations no. This is dot is nothing but a perpendicular, this is the direction of your electromagnetic wave in all the directions no. Therefore light electric field vectors are having perpendicular oscillations now. So therefore it is said to be like unpolarized light no. So but what we are doing now, we are blocking of all this no, we are allowing only one particular direction no. So that is said to be like a polarized light. So still if you do not understand no, therefore now we are going to discuss one experiment no. So therefore with that experiment you will understand very clearly. Clear? So therefore, so this is a right a denotion, we are going to denote it no. Therefore this is a polarized light. So these type of directions are nothing but along the, so these vibrations is along the plane, right. So it is plane of right parallel to the plane of this one no. This is now perpendicular to the plane of this one. Clear? So this direction is said to be like a perpendicular to plane of vibration. This is along the plane means parallel. So these are the two vibrations no. These two indicated as like a polarized light no. Unpolarized light we can have dot is there no, and there is a arrow is there. This is the symbolic representation like a unpolarized light. Now what we are doing now, we are separating only along one direction, either along the parallel or along the perpendicular to this one no. So that is said to be like a polarized light. These points are slightly important. Okay, still if you do not understand no problem. Now so I am going to explain one concept no, therefore you can get the clarity now. Suppose we will do one simple experiment to understand. So here I am going to take one cardboard sheet here no. So I am going to take one sheet, you can do this experiment no. So therefore here there is a one cardboard sheet is there no. Right. So therefore in this cardboard sheet, no, therefore one small slit we are going to make it here, one small slit. So along this direction now, right. So this is a slit now. Now what we are going to do now, therefore we are going to pass a one rope through this one rope through this, clear. Now what we are going to do now, suppose this rope, no, now what I will do now, I will make an oscillations like this, I will make an oscillations like this. So however this opening it is there now, it will be able to pass through it, no, definitely the wave it will be able to pass through it, clear. So therefore there is no disturbance now. But suppose one light wave which is traveling along this direction, no, so therefore what will happen now, so which is traveling along this direction, no, so therefore this is getting blocked due to this one, because this side oscillations are not there, so it is blocked, it will be not allowed to move toward this side now. And still some other one more it is there, no, suppose here there is a like this wave is there, no, this also it will be able to block, no, therefore this type of wave also it will be not able to pass through it, in which along this axis which is there, no, so in that direction only therefore the wave it will be able to pass through it, no. So this is said to be like a unpolarized light, unpolarized light. So this is said to be like a polarized light, you understand, no, polarized wave and unpolarized wave, clear. So therefore simple thing, no, you can just take it, no, therefore suppose this is one slit, no, so this is one pen here, no, therefore here it is there, if I am oscillating like this it will be not able to oscillate here, no. So if suppose if you are oscillating like this, no, therefore it will be able to oscillate. So other than the direction, no, therefore if I am oscillating like this, no, therefore the vibrations are getting blocked by this slit, no. So therefore remaining all the vibrations, no, getting blocked, no, only one along the plane of this one which is there, no, in that direction the wave it is coming out, no. So this is said to be polarized light, this is said to be like a unpolarized light, clear. So in this way, so you can understand very detailedly, this is nothing but one polarizer or polarides, you can take it, no, polarides, no, therefore this one. Suppose what you are going to do now here itself, okay. So now what you want to do now, what you want to understand here now, whether this light is said to be polarized light or not, no, how to identify it now. So how to identify whether this is a polarized light or not, no. So therefore for this one now, a single polarizer is there will not be able to identify whether it is a polarized light or not. Why? Because if you rotate here, no, so in that direction which wave is there, no, that wave it will be coming out, remaining other it will be blocked, no. If you are rotating this one single polarizer, no, so therefore this wave cannot be able to change its intensity, no. So therefore with this polarizer, no, with this polarides, no, so you are not able to identify whether this light wave is said to be polarized or not, no. For this one more polarizer is required, no, so that is nothing but we can call it as analyzer. One more polarizer is required here now, therefore here again one more slit is there in the same direction here, no, same direction suppose here, no. So therefore what will happen now, this wave, so it will be able to pass through it now very easily, so without any shown effect onto this. So when this said to be parallel, so therefore the wave which is coming here, no, the intensity it will be also same, okay. So but now what you are going to do now, okay, now it is both are said to be their optical axis is there, no, when they are parallel, so therefore there is no change in the intensity. Now this is, you can call it as like a analyzer. Now what I am going to do now, I am going to rotate this one now, I am going to rotate this. So what I am going to do now, therefore I am going to rotate it now. Therefore when I am rotating here now, therefore what is going to happen now, see suppose here I am going to rotate it now like this, okay. So I am going to rotate it like this. Now what happens now, when I am rotating, so this light wave is getting blocked because it is having only along this direction, no, but here it is along this direction the intensity is not there, so intensity is not present on this one now. So due to this rotation intensity is getting decreased, right. So if this is polarized light, no, by rotating this analyzer, therefore the outcome which is there, no, that intensity is going to get decreases. If the intensity decreases, therefore that type of light is said to be like a polarized light. You are understanding? Polarized light. Suppose, so here if you are rotating now, suppose now what you are going to do now, we are going to rotate here now. So due to this rotation, therefore this intensity will not change it now. So if you are rotating one polarized now, if you are, the intensity coming out is not changing, so that said to be like a unpolarized light. Right. So due to this rotation, no, therefore if it is unpolarized light is falling, therefore while rotating along this direction is there, that wave is coming. If you are rotating along this direction, no, along that which wave it is coming there, no, that wave it will be able to coming out, no, therefore it is said to be like a unpolarized light if the intensity do not change. But if that polarized light falling on this one, now if you are rotating, the intensity changes, then it is said to be like a polarized light. This is the confirmation now we can able to get it. Clear? So therefore here how much amount of intensity is changing, how to calculate about the intensities, no? So that was given by Malus law. Let us see what is this Malus law. So very important, no? Malus law. I think you understood very clearly. So therefore, so what is the polarized light and Malus law, right? So now suppose here, no, therefore here there is a, this is your angle, therefore angle of their optic axis now. Listen carefully now. Suppose this is an I is the intensity which is coming and falling, no. This is unpolarized light intensity. Listen carefully now. This is your intensity of unpolarized light, no. Now when it is passed through the one polarized, no, the intensity what is going to happen, no, intensity will become like a half. So no need to apply anything, no, therefore intensity is going to fall off this one. This intensity I name it as like a I naught. Clear? So don't confuse in this point, no. So this is the intensity of unpolarized light passing through the first polarized, no. So the intensity will become like a half of that. So that I am taking as like a I naught. Now therefore this I naught is coming and falling on this one, no. This I naught, it will be changes because of due to this changing axis on this. So the intensity which is coming out from this one now, that is said to be like a I naught into cos square theta. So the intensity coming out from this after analyzer is nothing but a I naught into cos square theta. Clear? So therefore here first of all what you have to do now, therefore first what you have to do now, first polarizer is there, no, the intensity coming, no, that it will be the half. Next, how many number of polarizers are there? Analyzer means nothing but one more polaroid only. How many number of polarizers are there? So that many times this formula you have to apply it now, right? So first itself you should not apply. Therefore first itself I and I naught. So there are not how many number of polarizers are there, that many times you can apply this formula now. So therefore here, so what you can rewrite it as now, therefore Malus law. So the intensity coming out from the polarized analyzer, so therefore this is I dash. So from this one, no, this is, you can call it as I dash, it will be equal to I naught is the intensity which is falling on the analyzer into cos square theta. Cos square theta is what? So theta is nothing but an angle between their optic axis. Clear? So therefore here what you can write it now, intensity is directly proportional to the square of the amplitude, no. So you can write down A naught, so square, so it will be equal to A naught into cos theta, therefore cos theta. This is the amplitudes which is coming out from the analyzer. Why? Intensity is directly proportional to the amplitude square. Clear? So this is I naught and A naught is the amplitude and intensity falling on this one now. Suppose if you take this is your intensity of unpolarized light, no, this is nothing but a I is equals to I by 2 as a I naught. So keep in mind, so this one, no. So if you do some questions, no, you can understand very clearly. Clear? So be careful, no, this it will be the analyzer, no, right. Suppose if you are drawing the graph variation of this intensity, therefore here this is your intensity I and with respect to the theta. So therefore here initially the theta is equals to 0, theta is equals to 0 means cos 0 is 1. So cos 0 is 1 means it is so maximum now, then afterwards it will be able to fall here now, and theta is equals to 90, 90 is nothing but a cos 90 is 0. So then it will be able to fall like this. This is your variation of the intensity, variation of the intensity. So with respect to the theta, so of our Malus law. So this is nothing but a z theta, therefore 0. This is nothing but a 90 degree. Clear? Na? This is nothing but a 180 degree. Clear? Na? Because whole square will be minus 1 will be equal to therefore 1 only. Clear? So this is your so variation and intensity and amplitude. No? So you can use these formulas. And polarization can also be obtained so by reflection. No? Therefore, that was observed by Brewster's law. Right? Polarization due to reflection. No? Therefore, here what is observed now? See here. Let us assume that here this is one. So one denser medium, no, maybe like a glass or a water or anything, no. Therefore, here. Now this is your denser medium. This is your rarer medium. Now, so therefore, this unpolarized light is coming and falling on this point. Therefore, unpolarized light so was coming and falling. This is your unpolarized light. So dot and arrows are there. And therefore, here there will be here this is your angle of incidence now. This is, you can call it as like a angle of incidence. This light ray, what will happen now? It will be get reflected back. Now let us see. This light ray will be get reflected back, and some light ray will be get refracted back. Clear? So this is getting refracted back. This is your refracted ray. This is your nothing but a reflected ray. And Brewster's what he observed, no, he took one polarizer, no, so he applied at this point, no, therefore he rotated at this point. When he rotated, he observed that, so therefore the light wave, therefore he observed that after passing through this one, now intensity is slightly changing. So intensity is slightly changing means what? This wave is said to be polarized light. So slightly changing means some partially polarized it will be there. So then observed that okay, by reflection also some polarization can be obtained. No? Then he started changing the angle of incidence and angle of this one. No? Therefore with respect to normal. So trying to change the different angle of incidence. No? Therefore he observed that the reflected ray is completely polarized at one particular angle. No? That angle we can call it as like a angle of polarization. So that angle we can call it as like a angle of polarization. And also he said that one more point, no, therefore when this is completely polarized, how the polarization is there, no. So these waves are, electric field vectors are perpendicular to the plane of paper, no. Therefore how they are polarized, no, it is said to be like a perpendicular to the plane of paper. And also he said that, so when it is completely polarized, if it is polarized, so at that point, so one more thing is also happening. So therefore this reflected ray and refracted ray are perpendicular to each other. So the angle between them is said to be like a 90 degree. So when the reflected ray is polarized, no, therefore first one condition is either light ray is incident at a particular angle of incidence, no, that is angle of, that angle of incidence is nothing but an angle of polarization. So and or reflected ray and refracted ray are perpendicular also at that point also, therefore the reflected ray is completely polarized light. So therefore we can calculate, no, what is the angle of this one, no, therefore we can apply Snell's law at this point, no. So we can apply the Snell's law at this point. So therefore here suppose here refractive index is n1 and n2. So what you can write it now? So light ray is coming here, no, n1 into sin I. So IP it will be equal to, so this is nothing but a R. So therefore n2 is nothing but a sin R. Clear? But R value we want to calculate it, no. What is the R value? This is totally 180 degree. So this total is 180 degree. So 180 degree is equals to 180 degree is equals to, so IP plus 90 plus R. So this taken here now, angle of refraction can be written as therefore 90 minus angle of incidence now. Clear? So therefore here you can write down n1 into sin I, so is equals to n2 into sin of R value is nothing but a 90 minus I. So this is nothing but a cos, therefore taken here, no. So sin I by cos I is equals to n2 by n1. So this is nothing but a tan I. So this I is nothing but a angle of polarization, or IP is equals to tan inverse of N2 by N1. Clear? Clear? So suppose if it is like a, this is your air or vacuum, no? Air or vacuum, therefore N1 value is equals to 1. So therefore what you can write now, angle of polarization can be written as tan inverse of, so therefore N will be your angle of polarization now. Or sometimes you can call it as like a Brewster angle also. Clear? So in this way, therefore this reflected ray is completely polarized. If completely polarized, so when IP is equals to tan inverse of N, so then only it is completely polarized. So therefore here are reflected ray and refracted ray are perpendicular to each other, at that time also polarized, no. If any one of these condition is not satisfied, no, the reflected ray and refracted ray both are partially polarized. So you can write it, no. This is however refracted ray is partially polarized, no. So reflected ray is completely polarized when angle of incidence is, so angle of Brewster angle, no. Clear? And there will be one more method is also is there, no, that is right. So polarization due to scattering is there, no, therefore right. So right, in that way also you can get the polarized light, no. So these two concepts, no, so is enough for our portion, no. So then we will see some questions. Clear? Now we will see one question here, no. Therefore here right, find the output intensity. So I think it is visible. So if it is not visible, just concentrate on my words, no. Find output intensity if angle between analyzer and polarizer is 30 degree, no, right. So output intensity is nothing but a I dash, it will be equal to, so I naught into, so cos 30 whole square. Clear? So this I naught is nothing but a I dash is nothing but a I by 2. I is nothing but a, so the intensity falling on the first polarizer, no, into cos 30. Cos 30 is nothing but a root 3 by 2. So whole square means is nothing but a 3 by 4. So I dash will be equal to 3I by 8. So will be the output intensity, so coming out from the analyzer. Clear? Right. So now we will go for another question. Let us see. Right. Right, unpolarized light of intensity, so 32 watt per meter square passes through the polarizer and analyzer of an angle of incidence is 30 degree with respect to each other. The intensity of the light coming out from this one, just it gave the value, that's all. So therefore we can write it as like a I dash is nothing but a 3I by 8. So just now we did this question, same thing, unpolarized light intensity is given as, so the I value is given as therefore 32 watt per meter square. Clear? So therefore just now we did, no, 3 by 8 into 32. So how much now it will be? 8 1s are 8 4s are, therefore 12 watt per meter square will be the intensity coming out from this one. This is your answer. Clear? Now we will go for another question. Right. When unpolarized light of intensity I naught and amplitude is A naught is incident on a two polarized, no, having the transmission axis with an angle of 60 degree, what will be the output intensity and output amplitude, no. So therefore here same thing, so angles are different, that's all. So here what is given now, this is your I naught and A naught. Clear? So this is one polarizer, this is nothing but an analyzer. Clear? So therefore here when I naught is there, so therefore it will be I naught by 2, I naught by 2. So therefore A value we can write down. So intensity is directly proportional to the amplitude square, no, amplitude is equals to root of this one, no. So therefore here A naught by root 2 will be your amplitude coming out from this one, no. Then the transmission axis which is coming, which is having this one now. So what is this angle now? Therefore here, so this is nothing but a, so this is nothing but a 60 degree. Clear? So the intensity coming out from this one now, I dash, it will be equal to, so therefore here I naught by 2 into therefore cos 60 whole square. So cos 60 is nothing but a 1 by 2. So 1 by 2 means 1 by 4. I naught by 2 into 4, that is 8. It will be your answer. So therefore A dash is equals to, so therefore intensity which is coming out from this one now, coming in this one now. So A naught by root 2 into cos 60. So therefore A naught by root 2 into cos 60 is nothing but a 2. A naught by therefore 2 root 2 will be your answer. Clear? So therefore this is the our amplitudes and intensities. Clear? Now we will go for another question. Right. So two polarites now P1 and P2 are placed with their axis perpendicular to each other now. Therefore, here what is given now? This is one P1 and therefore here P2. So how are they now? Perpendicular to each other. Correct? So an unpolarized light of intensity, so which is coming as I naught in this one now, is incident on the P1. A third polarized now P3. There is a P3 is kept in between this one now, such that it is going to make it as like a, so transmission axis of about 45 degree. Therefore, here this it will be the P3, it is there now. Therefore, what is given now? It will become like a, so 45 degree, compulsory the angle between this one is also nothing but a 45 degree. Clear? So this is I naught. So I naught means what will happen now? So here passing through this one now, I naught by 2. Here you have to apply the one Malus law here. So what is this one now? Therefore I dash through this one now, I dash is coming out. So therefore falling on this one is I naught by 2 into cos 45 whole square. Cos 45 is nothing but 1 by root 2, whole square is nothing but 1 by 2, I naught by 4. So this is I naught by 4 we are getting now. Again you have to apply the Malus law at this point. So therefore here again Malus law, what you will get it now? I double dash is nothing but a, so I naught by 4 into again cos 45 whole square. So therefore 1 by root 2 whole square is nothing but a I naught by 8. So this is your I double dash. So this is the intensity which is coming out from the second polaroid. Clear? So in this way, that's why I told you, first time you have to take it off half, like that how many number of polarides are there, just you make it apply the, so Malus law now. Now we will go for another question. Right. So plane polarized light is passing through the polaroid. On viewing the polarides, through the polarides, we find that polarides in one complete rotation about the direction of the light, one of the following is observed. A plane polarized light is passing, see here. So therefore here there is a one polarized light is passing through this one now. This is one polarizer. So this is your polarized light. Polarized light. I told you already. So therefore what he did now, he rotated this one now. He rotated, definitely the outcoming intensity will be changes. Clear? So outcoming intensity will decrease, again it will be able to comes to the 0, again it is going to become like a maximum now, right? So like that it will be happen now. Now let us see. The intensity of the light gradually decreases to 0 and remains at 0. It will not remain at 0. Why? Because so when it is becoming perpendicular, it becomes to the 0, again it will comes to the maximum. See, we drawn already here now. Therefore one comes to the 0, again comes to the maximum here now. The intensity gradually increases, no. So there is no change in the intensity, wrong. The intensity of the light is twice maxima and twice 0. So for one complete rotation now, therefore this is 0, this is 90 and this is 180, again this it will be the 316. Therefore this is 180, this is nothing but 360, therefore 2 times maximum, 2 times the minimum. So this will be a best correct option, no? So you can get it. Clear? Right? Now we'll go for one more question, no? Right. So here for a given medium, the polarizing angle is given as 53, right? So angle of polarization is nothing but how much now? 53 degree. What will be the critical angle of that medium? Right, very good. So we have to calculate first of all a refractive index, no? Therefore here, so therefore tan I it will be equal to n. So therefore tan 53, so it will be equal to n. Yes or no? So what you can write it now? Therefore tan 53, 53 means you know it now already. So this is 37 degree, this is nothing but 53 degree. So this is 3, 4, 5. Clear? Clear? So therefore tan 53 means is 4 by 3. So that is nothing but it will be nothing but 4 by 3. So will be your refractive index now. Therefore critical angle now, therefore what you can write it now? Sin C, it will be equal to 1 by n. C is equals to sine inverse of, so 1 by n. So therefore sine inverse of 1 by n is nothing but 3 by 4 C. Clear? Sine inverse of 3 by 4. So this it will be your critical angle now. Clear? So they may ask you what will be the speed also, they may ask you after finding this one, no, the refraction lesson whatever we discussed, no, so that all can be applicable, no. So they may ask you what is the wavelength, they may ask you velocity or anything they can ask, no. Clear? So right, now let us go for one more question, no. Yeah, this is already asked here, no. So for a given medium, therefore the polarizing angle is 30 degree. So what will be the speed of the light in that medium? Therefore so tan I it will be equal to n. So tan 30 it will be equal to n. Tan 30 is nothing but a, so therefore n value is equals to 1 by root 3. So tan 30 value. Clear? So that sin 30 is 1 by 2. So cos 30 is root 3 by 2. So 1 by 2 get cancelled out now. Root 3, right? 1 by root 3. Clear? So I got the refractive index now. Therefore speed of the light in the medium, refractive index can be written as speed of the light in the air 3 into 10 to the power of 8 divided by, therefore it will be, so speed, no. Clear? So V is equals to 3 root 3 into 10 to the power of 8 meters per second. Okay, so that means actually you can check it here. So this is practically it is not possible now. Why? Because so this refractive index is less than 1 no. Therefore the speed of the light is becoming more than the 3 into 10 to the power of 8 no. So practically this question is not possible, right? So therefore, but question is given no, just you can check it. Clear? Now we'll go for one more question. Yeah, so this is the NEET 2025 question now. Therefore lot of controversial it is given, controversial paper, right? So NEET 2025 question no. So let us see what is this question now. In NEET 2025, therefore they gave 2 questions from the polarization now. Clear? So intensity of the transmitted light. So when a polarized sheet placed between the 2 crossed polaroid at 22.5 from the polarization axis, if one of the polaroid axis of one of the polaroid, and therefore if I naught is the intensity of the polarized light after passing through the first polaroid, right? So therefore what is given now? So the intensity of the transmitted light is asking no. Therefore this is one right. So here, right. So the intensity of transmitted light when polarized sheet no. Therefore he is asking this is the intensity coming out from this one no. So placed between the 2 crossed, okay, 2 crossed polarized, right. So therefore here is asking no, right. So therefore these are the two crossed sheet is there. Therefore two crossed means what will happen now? They are perpendicular to each other. Clear? Huh? So crossed means, you remember that crossed means so perpendicular to each other. Clear? So now therefore the intensity of transmitted light when polarized sheet is placed between the two crossed one no, at an angle of 22.5 from polarization axis of one of the polarite. So that means what is doing now? Therefore here we are going to keep one more so polarizer no. Therefore this angle what is given now? He said that angle is nothing but a 22.5 degrees here now. Clear? Definitely this is 90 degree means how much it will be now? 90, therefore 90 minus 22.5 degrees. Keep it like this only. Clear? So therefore here I naught is the intensity of the polarized light passing through the first polarity. Therefore this is here I naught. Clear? I naught it is there. Therefore here maybe okay. So this is unpolarized light no, for here I by 2, but he gave I naught. After passing through this one now, therefore first polarite now, what you can write it now? So first polarizer, therefore I dash. So I dash can be written as I naught into cos square. So therefore angle is how much now? Cos square is nothing but 22.5. Clear? So therefore this one it is again passing through this one now. I double dash, therefore this double dash can be written as, so the intensity coming falling on this one now, I naught into cos square 22.5. This is the intensity coming and falling into cos square 90 minus 22.5. So therefore here I can rewrite it as, so therefore I naught into, so cos square I can write it as, therefore I will write whole square. Clear? So cos of 22.5 into whole square is there no, that is whole square I will write it no. So cos of 90 minus this one means sin of 22.5. So therefore this is whole square. Now what I will do it now? Therefore I will write it as here. So therefore I can multiply, therefore 2 I can divide by the 2. Therefore this 2 I will take it out onto this one no. This 2 if I take it out, therefore it will be the divide by the 4. Clear? So this I can rewrite it as, therefore I naught by 4 into, so 2 sin theta cos theta, therefore sin of 2 into 2 theta, sin of 2 theta, 22.5 whole square. Clear? So how much it will be now? I naught by 4 into sin of, so 45, therefore sin 45 whole square. Clear? Sin 45 is nothing but how much now? I naught by 4 into sin 45 is nothing but 1 by root 2 whole square. So therefore it will be 1 by 2, therefore I naught by 8. So will be your answer now. Clear? So this is your answer. Clear? Right students, I will go for one more question. This also one of your so NEET 2025 question. An unpolarized light beam is traveling in the air, so is incident on a medium of refractive index. Refractive index is given as 1.73, that is nothing but a root 3. Clear? So therefore here angle of polarization can be written as tan of n, therefore tan of root 3. So therefore it is nothing but a 60 degree will be your answer. So both okay, we will see therefore both reflected and transmitted light are perfectly polarized with angles of reflection and refraction close to 60 degree, and angles of reflection is 60 degree and refraction angle is how much now? We have to check it no. Refraction angle of refraction is how much now? 1 into sin 60 is equals to n is how much now? Root 3 into sin r. So sin 60 is nothing but a root 3 by 2 is equals to root 3 into sin r. This will get cancelled out now. 1 by 2 is nothing but a sin 30. So therefore r it will be equal to 30 degree. Clear? So therefore, okay, this angle of refraction is not 30 degree, reflected ray is completely polarized and angle of reflection is close to, okay, angle of reflection is completely close to 60 degree, reflected light ray is partially polarized, angle of reflection is close to 30 degree. No, this is wrong. Reflected ray is completely polarized, angle of reflection is close to 60 degree, this should be the correct one now. So both reflected and transmitted light rays are partially polarized with an angle of, so with a close to 60 degree means completely polarized. No, therefore this option will be wrong. No, so this option will be a correct answer. Clear? So it made you to confuse here. No, clear? Perfectly polarized, sorry, here perfectly polarized, so perfectly polarized with an angle of close to, this should be your correct answer. Reflected light, oh sorry, both reflected and transmitted light are perfectly polarized, therefore this is wrong. Why? Because transmitted light will not be polarized. Clear? So therefore reflected ray only, it will be completely polarized, so that it will be your correct answer. Clear? So this type of confusion it will be there. So in the competitive examinations, no, let us. Right, we will see one question here. No, therefore this is one of the interesting question which is given in JEE Main 2025. No, so JEE, very interesting question. No, clear? So now let us see here polarization and Young's double slit experiment. No, therefore is combinedly here. No, what he did. No, therefore in Young's double slit experiment there are three polarizers are kept in the figure. No, the transmission axis of P1 and P2. There are, I think you can able to see it. No, therefore if you are not able to see, just please try to observe here. No, so that I need not to draw the diagram one more time. So here there is a one more polar P1 and P2 are there. No, therefore are orthogonal. Orthogonal means to each other, they are perpendicular to each other. No, and the polarizer P3 are both the slits, no, are transmitted with a 45 degree. This is making like a 45 degree with this one, no, 45 degree with this one. No, clear? So therefore here to this one. No, and an unpolarized light of intensity is I naught is incident on the P1 and P2, right? The intensity of, and after that one, no, P3. Therefore first intensity is coming toward this side, then afterwards intensity coming toward this side. We want where the path, okay, we want to calculate the intensity at a point after P3 where path difference is given as lambda by 3. So here both the things now we have to calculate. First of all, let us calculate the intensity of passing through this one. No? First this is unpolarized light of intensity. Okay, I will draw it, no, so that you can get the clarity here. No, so this is one polarizer. No, this is another one more polarizer which is kept in between these two. So therefore right. So here one more big polarizer is there. So he is asking the intensity at certain point. No, so through this one, no, therefore intensity is I naught is coming. No, so you know that after passing through this one, no, definitely. So this it will be the I naught by 2, I naught by 2. First time it is passing through this one. No, so we will take it as like a I naught by 2. So through this one now I naught by 2 it will go, I naught by 2 it will go. No, so but what it is the angle making here now? Angle it is making like a 45 degree with this one, no, and with this one. No. So we will apply the intensity coming out from this one, no, intensity coming out from this one. No. So by using the Malus law, therefore I is equals to, therefore intensity coming out from this. So therefore what is falling now? I naught by 2 into cos square 45. Cos square 40, cos 45 is 1 by root 2, whole square is nothing but a I dash is nothing but a I naught by 4, I dash is nothing but a I naught by 4. And these two waves now will go superimpose now, therefore, so will form like a interference. No, so will form like a interference. No, so then we want to calculate the intensity at that point. Clear? So interference, so what you can write it now? interference formula, I is equals to therefore 4 I naught into cos square. So 5 by 2 will be your phase difference now. So what is up? He gave the path reference is how much now? Lambda by 3. So we can calculate the phase difference here now, right? So therefore phase difference is how much now? Phase difference is nothing but 2 pi by lambda into lambda by 3. So lambda cancel, 2 pi by 3. So will be your phase difference now. Therefore here what you can write now? 4 I naught. What is the intensity? So 4 I naught, therefore here, so I naught is the intensity here now, therefore I naught by 4 into, so into cos of 5 value is how much now? 2 pi by 3 divided by 2 into whole square, clear? So therefore this can be written as now I naught into, so these two get cancelled out now. Pi by 3 means 60. So cos 60 is nothing but a 1 by 2. 1 by 2 whole square is nothing but 1 by 4. So therefore I naught by 4 will be your correct answer now. Clear? So this is I naught by 4 will be your correct answer for this question now. Right? So very good question. So which was framed in the JEE mains no. So go through it. Now we'll see one more. Okay. So, right, so we already discussed the polarization thoroughly, all the different problems we already covered, right? So regarding the polarization, no. So in time, therefore, if any new questions, if I see it, no, definitely I will come with one more video regarding the polarization, or we will do some videos, no, whose wave optics completely like one separate type of questions, no, like that also will come, right? So here wave optics is completed, no. Therefore, thank you for watching. Please subscribe and share these videos, no, so those who want to learn physics. Thank you.